members. Good afternoon to you all. I welcome you, Madrin. You have found Arvin and Atieng here. So I remember I left you with an assignment on how to draw a cross-section. I only received the work of Atieng. Calvin, did you submit?
Yes, sir. I think I did because I did the work. I'm not sure if I submitted it or not.
I haven't received your work. Madrin, did you submit work of the cross-section?
No.
What are we waiting for? But did you do it?
I tried. Yes.
Any challenge you found in doing that work?
Yes.
You can mention it.
I tried to watch the video and do the work, but what confused me is putting them on a paper and drawing them. Because I tried to do what he was doing. I first measured, I got the measurements, but then allocating them the exact way they were, I failed.
Do you have a graph paper?
Right now, no.
It's better if you have a graph paper or a graph book. It's easy for you to draw a cross-section rather than using a flat plain paper. I mean, rather than using a plain paper. If you have a graph paper, it's easy to plot. Let me hear from Atieng. Which challenge did you meet? You sent in your work? Tell me the challenges you met in doing that assignment. Vitalis, you are on, please speak.
Yes, sir.
Which challenge did you meet when you were doing the assignment of cross-section?
I didn't meet any challenge.
Okay, Calvin. Calvin. Okay. So we are supposed to look at two things: vertical exaggeration, intervisibility. And then later, we can go ahead and look at the horizontal equivalent, or call it the horizontal distance. So when you draw a cross-section, the questions that follow there, we normally ask vertical exaggeration and maybe vertical, intervisibility, and at times horizontal distance, call it horizontal equivalent. So vertical exaggeration, if your map extract, let me open your map extract. So if you find that your map extract, it is in meters or it is in height, here we are saying that if the contours are in meters, your scale will be horizontal scale over vertical scale times 100. But if the contours are in feet, you will use horizontal scale over vertical scale times 30. Let's look at this map extract. So when you look at the bottom here, bottom left, contours here are in feet. Contours here are in feet. So that means that, let me first get someone's work. I use it. going to use the one of Atieng. Atieng, did you send the cross section on email?
Yes, sir.
It was on email.
Yes.
Okay, let me first get it shorted here. Because we need to use at least a cross section that is ready. It's 5. Did you send this work? When did you send the work of map work? The one for cross section? Atieng?
Actually, sir, I've forgotten the date.
You've forgotten the date. Okay, let me check out here and ensure that I've opened the right. Okay, moment. Okay, I've seen the work. So when you look at this work, this was the work for Atieng. I'd like to give you feedback. I'm still looking at the marked work, but the reality is this work is still lacking. I think I'm going to send you feedback immediately after this class. But what we need to know is, one, this work must have these ones. You must state, for example, height in feet. It must be there. Then also put the same values this side. Put the same values that side. And then after writing your title, I expected here for you to state the scale. You are supposed to state the scale there. Then after stating the scale, I also expected the, okay, I think this one is okay. Now, if you get this minus this, what did we get? Is it 300? Isn't it? Members, am I speaking alone?
It's 300.
Can you, members, can we keep our mics open? 300. So this 300, what do we call it? What's the name given to that? We call that on the amplitude. We call that amplitude. Getting the highest contour minus the lowest contour. What you get is called the amplitude. Now, going back here to our content in the unit, to get the vertical exaggeration, how do you get the vertical exaggeration? We are saying you get the horizontal scale over the vertical scale. Atieng, what was your scale? So when you look at this, she was using a scale of 50. Isn't it? 1
Yes.
centimeter representing 50 feet. That was your scale. Right?
Yes.
Yes, that was your scale. So let me share a whiteboard. Now here, to get the vertical exaggeration, we have said that, first of all, we shall get vertical scale. Moment. Let me reduce the font size. How do we get the vertical exaggeration? It is we have said that to get vertical exaggeration, you get horizontal scale over vertical scale. You get horizontal scale over, put a line, over vertical scale. Now, remember our map extract, the units were in, let's check again. Oh, the units are in feet, okay? So once the units are in feet, we shall multiply by, here,
30.
we are multiplying by 30. Good. We are using 30. Get back the whiteboard. So we multiply by 30. And so what is our horizontal scale? Remember our horizontal scale was 1 to 50,000. The one on the map extract. That is the horizontal scale we are meaning. This. Are we together? That is the horizontal scale. Okay. Then divided by, we have used 1 centimeter representing 50. That was your scale. Then multiply that by 30. Okay. Now, simple. What we need to do here is we first get this one is the same as that. So we are looking at 50,000 over 50. What did you get?
Yes.
50,000 divided by 50.
1,000.
You get 1,000. Is it? Members, is it what you get?
It is 1,000.
Let me leave you to calculate this. When you're done, you tell me we are done.
It's 1,000.
No, I want all of us to be active. First of all, we are saying, let me first put down here what we are supposed to use. Scale, vertical scale, we have 1 centimeter representing 50 feet. Then horizontal scale, we have seen that this is 1 to 50, 1 to 50,000. Then I have given the formula as a moment. I have given the formula as that horizontal scale over vertical scale times 30. Calculate that and you tell me the answers. How many minutes are we using? We are using 5 minutes, and we display our final answers.
One. Oh, pick one.
Hello? Is this thing going to give us the right answer, or we have made a reciprocal?
Me, I'm getting 1 point. Say 1,500,000.
I think it's reciprocal. We need to. Yes, it was supposed to be vertical scale over horizontal scale. There's something correct there. Correct that, and then get the answer.
Actually, the case for the horizontal scale, how it's supposed to put it?
As what?
Let's divide 1 over 50,000. Sorry, horizontal scale. We use 50,000.
Yes, this should 150,000.
My answer is 3,000 feet. I've divided 1 to 50,000 divided by 1 to 50. Then I multiply by 30 to get 3,000 feet.
Yes.
So things we are using vertical scale over horizontal scale. Over horizontal scale times 100. Times, this is feet times 30, okay? So we are saying that our vertical scale is 1 to 50,000, 1 to 50 feet. So clear one. Text. Vertical is 1 to 50. That was the scale used for vertical. Then over 1 to 50,000. Okay. Then times 30. So that means that what we are getting here is what is 50 times 30? 50 times 30. 50 times 30.
1,500.
1,500.
Yes, 1,500. So get 1,000. 1,500.
Divide
Then
by. We're going to divide
divide by
by.
1,
What is
150,000.
Hmm.
Okay. Then from there, it means that we shall have to get 1.
Excuse me, teacher.
Please.
I thought you were multiplying the whole thing times 30. The
No,
vertical scale divided by the horizontal scale.
No, the 30 is for the upper figure.
Oh, okay.
Yes. So that means that from there we shall have
So the answer is 33.3.
Yes, let's put it together and put it there.
1, 2, 1, 2.
1 over 1,500, then divided by number that symbol divide by 1 over 50,000. Okay, so after doing that, we shall have
God forbid.
what's up of returns. Next, that means that we shall basically now get like this 1 over 150,000 times 50,000 over 1. So that means that automatically this is crossed with this, and then you remain with 50,000 over 1.
So that's 5,000. The one you wrote up here.
So that means that now we have 50,000 divided by 1,500. What's the answer? 50,000 divided by 1,500. What have you got?
It's recovering.
We have got together
Okay.
something like that.
It's recurring.
Yes.
Yes.
Okay. That was the vertical exaggeration. And then continuing to next was to look at getting the VE, vertical exaggeration. Now we need to calculate gradient. Calculate gradient. After calculating gradient, then
It's a vertical rise divided by the horizontal equivalent.
Okay. Now, but before that, we need to know horizontal equivalent before we proceed. Horizontal equivalent. Horizontal equivalent. Basically, horizontal equivalent is horizontal equivalent here is here 5.9. 5.9, that's the horizontal equivalent. We get that? You just measure this distance from A to B of your cross section, and there you get the horizontal equivalent. So if we want to determine gradient here, what did we do? How do we get gradient here? We have said that what? Vertical rise over
Equivalent.
we have said that it is vertical rise over horizontal equivalent. Now our vertical rise from our cross section is, you get this highest contour minus lowest contour. What you get is the vertical rise, the one we call amplitude at first. So we calculated 300,000.
Just 3.
I mean 300. So that means that we shall get 300 over. Now this one must be turned into kilometers. This must be put into kilometers. I see. Okay, I don't know if this one was written 5.9, but actually it was supposed to be put in meters. Supposed to be put in meters. Let's do it practically here. I share again the whiteboard. Vertical rise. Share the whiteboard. So we have said that you get, it is VR over horizontal equivalent. So our VR is 300, and then over, we had 5.6. So when you put it in our kilometers, we shall have it like that. So from there, what do you do here? So that means that here we are changing it from kilometers, we are changing it from the kilometers to our meters, so that we have similar measurements. You get? So from there, it means that we shall have by definition, because I want us to get this from the definition. By definition, horizontal, by definition, gradient, we say that gradient basically is the amount of rise or fall of the land in a certain horizontal distance. It is expressed as a ratio of vertical rise to horizontal distance. And now, what does it mean? In order for you to get it very well, it's like you're getting this divided by 300. So that at the end of it all, you have a clear ratio. But what do I mean here? When you get this, these ones will go. So it means that when you get when you get 56 divided by, let me undo this and we do it well. When you get 56 divided by 3, what do you get? 56 divided by 3?
18.6.
18.6. That means that here, let me use a different color. That means that here,
60.
it is going here 1, and then here it is 18.6. You said 18.6?
Yes.
You can round off to 19.
7.
So that now our ratio is 1 to 19. Do you get that, members?
Yes.
Yes, that is our ratio. What you can call the gradient. We said gradient is horizontal I mean, you get vertical rise over horizontal equivalent. Vertical rise, we got this from our cross section. We got this from our cross section here, where we got this minus this. The highest contour on the cross section minus the lowest contour, we got 300, and that is what called the vertical rise. Then put this in meters and get a ratio. Next, we are looking at intervisibility. Intervisibility. Now, with intervisibility, for example, here, if I can ask, intervisibility, what does it mean? If I press something here and another thing is here, and I say this is A, and I have B. Do you think A is in position to see B, or B is in position to see A?
No.
Why do you think the answer is no? Why do you think the answer is no? Because of this barrier, right?
Yes.
Isn't it? But if a feature is here and another feature is here, it means that here these two are visible, but A is intervisible from B. Even if some feature is here, this is visible from here, and this can be visible. For example, if I call this C and I call this D, see D, these two are visible. These two are visible from one another. These two are visible from one another. That is what we call the intervisibility. C and D, whichever point you are, they are visible. But because of the barrier between A and B, these two are intervisible. That's what it means. So this question is always common on cross sections. Okay. Next. Anyone with the question? Anyone with the question? So today we have looked at vertex exaggeration, intervisibility, gradient, horizontal equivalent. This one I say you measure this distance here. You just measure this distance here. From here to here. After measuring it, you now take it to your map extract at the bottom here. And measure. You measure from here. So Vitalis found it to be 5.6. Any other question? Now, what we are going to do is we shall continue to read at our pace. We continue to read now from here, physical or physiographic representation. I will send an activity here. You are now going to study how to represent the relief features on the map. You need to understand if these are steep slopes, even the fact your map extracts that you downloaded, slopes, etc. So read about the relief representation, all these ones. I'm going to send an activity before this week ends, so that you tell me that you understood the relief representation. And these diagrams are very clear for you to understand. Very clear, well illustrated. So today, that's what we were supposed to cover. I will send an activity. Calvin and Madeleine, please send in your cross sections before we go to the next topic. Is that okay?
Yes.
Where you get a challenge, please come to my inbox and be here. Otherwise, I'll keep you in the name.